A complex fraction is a fraction whose numerator and or denominator contains one or more rational expressions. To simplify a complex fraction, you should follow these steps. First, add or subtract the expressions in the numerator to form a single fraction, and add or subtract the expressions in the denominator to form a single fraction. More often than not, that's going to involve getting an LCD. 2. Divide the rational expressions from step 1 by multiplying the numerator of the complex fraction by the reciprocal of the denominator of the complex fraction. And then finally, simplify as needed. So we have the complex fraction 2 plus 3 over x, all divided by 2x squared over x plus 3 minus 3. So what we want to do is we're going to try and multiply the top by the LCD here to get a single fraction, and then multiply the bottom by the LCD to get its own fraction. So the LCD of the top is just x, and the LCD of the bottom is x plus 3. So what I'm going to do is I'm going to multiply the top by the LCD, so it's going to be x over x, and in the bottom I'm going to multiply by the LCD here, which is going to be x plus 3 over x plus 3. So when I do that, take this, when I do that, I'm going to end up getting 2x over x plus 3 over x, all divided by 2x squared over x plus 3 minus 3x plus 3 over x plus 3. Now from here, I can combine each top and bottom by with the LCD being the same, and I can get 2x plus 3 over x, and then 2x squared minus 3x minus 9 divided by x plus 3. Now I have a fraction up top and a fraction at the bottom, so I can now move on to the next step and multiply it by flipping it. So the top, 2x plus 3 over x, and the bottom, x plus 3 over 2x squared minus 3x minus 9. Now, nothing I can cancel out here because there's nothing in common, but I can factor this quadratic down here. So while everything else remains the same, the denominator actually factors down to 2x plus 3 and x minus 3. And from here I can just cancel out the like terms. The 2x plus 3's gone. So nothing else can cancel, so I just write out what I have left, which is going to be x plus 3 up top, then x times x minus 3 in the bottom. And this will be the expression simplified. Now this one's a little bit more complicated, a lot more going on, but it's okay. So we have 2x plus 1 divided by x minus 1 minus x minus 1 over x minus 3, all divided by x squared minus 3x minus 4. So I don't have anything in the denominator that's a fraction, so I can just leave it as is. But in the top, I got to find an LCD, which is going to be x minus 1, x minus 3. So I'm going to multiply the entire top by the LCD, top and bottom. So x minus 1, x minus 3 over x minus 1, x minus 3. Now, when I do that, take it over here, I'm going to get 2x plus 1 times x minus 3 over x minus 1, x minus 3 minus x minus 1, x minus 1 over x minus 1, x minus 3, all divided by x squared minus 3x minus 4. Now I got my LCD up top, so I can combine the fractions together, and I'm going to get 2x plus 1, x minus 3 minus x minus 1, x minus 1, all over the LCD, x minus 3, all over the denominator. And now I can distribute the top, try and simplify it a little bit more. So when I do that, I'm going to end up getting 2x squared minus 6x plus x minus 3. And then for the other one, I'm going to get x squared minus x plus 1, all divided by the LCD, all divided by x squared minus 3x minus 4. And we're still going, so now I can combine like terms in both parentheses. So I get 2x squared minus 5x minus 3. And when I combine this, I'm going to get a negative x squared plus 2x minus 1, because I took this negative and distributed in after combining like terms, all over x minus 1, x minus 3, all divided by x squared minus 3x minus 4. Now I can combine like terms up top, which is going to give me x squared minus 3x minus 4 divided by x minus 1, x minus 3. And because this is essentially over here divided by 1, the bottom, I can just flip it and multiply. So I'm going to get 1 over x squared minus 3x minus 4. And now, thankfully, I'm at the end. These can cancel right out. And I'm left with 1 over x minus 1, x minus 3. And so this, finally, is the solution to our original expression.